5, 4, 3, 2, 1.
Hello? Can you guys hear me? Let's see. Sorry, this is my first time doing this, so I'm not very experienced. Let's see. Alright. So, can you guys hear me? Alright. I'm just going to assume that you guys can hear. And let's get started. So, pretty much, we're designing a new rocket, and because we're doing this cool little project, and that's the whole point of this rocket motor test stand here. We're doing a new project, and in the project, I'm not going to get too much into it. We're going to need to design a new rocket. So, well, that's what we're going to be doing today. So, as you can see here, we have the SD's website up. We're going to be just going through everything here, and then, yeah, we're going to be finding the parts, and then we're going to be designing, kind of just going through parts and designing the rockets. At the same time, I'm just testing this whole system out. We're using OBS Studio and to see how this works. So tell me if you have any suggestions or anything, if you want me to do anything, and type in the chat if you have any questions at all, any suggestions. I'll be asking you if you have any like advice or anything, and you don't need to reply, but it'd be nice if you do, because it's kind of awkward just talking to a laptop here. But anyways, let's get started. So I have this little spreadsheet up right here. We're going to be just looking through and kind of designing our rocket here. So um, I so first of all, we're going to want it to fit a 29mm motor, and I've chosen a motor out. Let me see if I can find it. I'm probably going to be using a composite motor. Let's see, F15 rocket motor. I think Walmart had a few. So I think it's the Aerotech F39W or something. Let me see if I can find it here. And the reason we're getting it from Walmart is I don't think they have that $35 hazmat fee. Oh, right here. Is this it? No, that's not it. I'll keep scrolling. Right here. That's it. Right here. So there's only 3 left, so don't buy these all out because I want to get just 1 pack of these. So the reason I want to get it from Walmart is because there's no hazmat fee, I don't think. Correct me if I'm wrong. So anyways, we're going to fit this motor right here, and then we're going to be using, in the SD's website, we're going to be using the Pro Series 2 parts right here. So I had this idea, and I was wondering if you guys wanted to give me advice on this, because I'm not like a super good amateur rocketeer. So I was thinking, the ST's website, they don't sell fins anywhere. And I was thinking just for the fin assembly and the motor mount, and they don't sell they don't sell motor retainers. They sell they sell these, but they don't sell the centering rings for the motor mounts for 29mm motors. So I was thinking we could just get one of these boosters, and I have it somewhere here. Let's see. I got the booster somewhere. Ah, right there. I'll be right back. So right here, like you can see right here, I have the booster, and I was thinking for the rocket, if we could just make the booster itself, because this comes with the motor mount and the fins and everything. It's really a nice design. I was thinking we could just use this as just the fin assembly and the motor mount assembly, and just glue it onto the rocket. This part, the coupler, onto the rocket body tube, and then we'd have pretty much a pretty cool rocket with fins and the motor mount there. So in the chat, if anyone thinks that's a horrible idea, or if you think it's a good idea, go ahead and put that in. So I don't feel like I'm just talking to a blank screen right here. So anyways, and then this right here is a Pro Series 2. Let's see. What's the dimensions of this? I think this goes on the 2-inch rocket. So we're going to have to get the 2-inch body tube right here. So this is 2 inches by 13.5 inches. So I think 2 inches is a 51mm body tube, same as our Majestic rocket over there. Oh, cool. So, oh, I see you put stuff in the chat. Cool. So let me read that. So, Robert Kiefer, sorry if I butcher your name. See if there's a local NARTRA rocketry club that you can join. They will likely have vendors at their launches that you can buy motors from at near cost without having to worry about hazmat fee. Yeah. So, I have a mentor here in our city here that has a ton of motors, and he gives the motors out. So he doesn't give them out. He gives them to our club because he's one of our supporters along with Patreon. So he's lent us the F15 motor that we tried with our test stand here. And I can see Jared Herons over here. He's one of our code contributors. But anyway, he lends us those rocket motors, but I don't think he has any of those composite motors. And as for the NAR Rocketry Club, we are in one. It's called Zia Space Modelers, and that one, they don't have any vendors or anything, especially with the coronavirus. Our launches are completely restricted, so we're gonna have to buy them from, I think, here from Walmart. And yeah, I think this motor is actually pretty nice. I think it's 88 newtons of power. I think this will actually work really nice with our rocket. So it's only $12.12. So I think that's better than the $35 fee. But anyways, yeah, that's a good suggestion though. But we live in a kind of secluded area here. In New Mexico, so we don't really have, that many clubs going around with vendors and stuff. Jared Heron says, try to find a thrust curve for it for takeoff thrust. Yes, that is what we are doing. So we're gonna stick that motor inside this test stand, use the code that you contributed along with our calibration code, and we're gonna get an awesome thrust curve for this. And I'll go ahead and tell you guys the kind of what the project is, just as a thanks for coming out here and not making me feel lonely. So we're doing this science fair project kind of, where we're the problem. Every science fair project has to have a problem. The problem is so many pilots are dying, or military pilots. So we're making a drone UAV that launches a model rocket off of it. But the problem is launching a model rocket off of a flying drone is illegal, because the Federal Aviation Administration considers a model rocket as a weapon. So we can't do that. So for our science fair project, we're going to say we're going to do these little tests on the drone, seeing if the drone can handle a rocket launch off of it. So if you want more details on that, you can go ahead and put that in the chat. But that's kind of the gist. And then we're using the thrust stand to find out all the data. That way we can test the drone using the data from the stand. So I'm my friend that's also in this club, one of our members. He's making the drone because he's expert at making a drone, and then I'm designing and making the rocket along with another member. So we're just working on this. So I'm thinking about getting this Aerotech F67 9W motor right here. And I looked over on Apogee Components, Aerotech, let's see, F67 here. So we have this motor, and then it gives us the details here. So 88 newtons, that's kind of a lot of thrust. So, and we have kind of a smaller drone. We can always make a newer drone, but it's costs and stuff anyways. So we're going to be just we're going to try using this motor. So 88 newtons, let's see newtons to grams. Let's see if our 5 kilogram load cell can handle 88 newtons. So convert, copy that, grams to kilogram. Oh, I probably didn't need to do that. So 8 kilograms. So we're gonna have to swap out this load cell here if we do end up using this motor, because 88 newtons is a lot. Or we could just use the SD's black powder motor, the F15 motors. But if you look on SD's, they're out of stock and they're not in stock into fall, and then they have that hazmat fee. So I think that our sponsor, our mentor type dude, he has some motors there that we could use, but I'm not sure. I think we used them all up. So anyways, yeah. So if we do end up going with this motor, that means the drone might not be able to handle it, first of all, and then second, we're gonna have to replace this load cell. So I don't know if we should use this. So what do you guys think? You think we should use this Aerotech motor, or you think we should just go with a F15 SD's black powder motor? So while you guys put that in the chat, answer that question. Let's see these dimensions. So we got 2-inch by 13.5-inch. So let me bring out a rocket real quick. I want to see the dimensions of that rocket because I kind of want to have the same design. So I'll be right back. Alright, so Robert Kiefer, I hope I'm saying your name correctly. Sorry I missed this, what the project was about. Where does the drone fit into this? Alright, so I'll go into the whole project details. So the problem is so many people are dying from combat situations from fighter pilots in the military. So we're proposing that we use a UAV, or an unmanned aerial vehicle. So we're starting out with a small prototype, a drone, and then a drone with a rocket, and the rocket simulates a missile, the drone simulates a UAV. But the problem is we wanted to do this, but the problem is launching a rocket from a drone is illegal because of the Federal Aviation Administration, or the FAA. So what we're going to do is we're just going to get motors and then test them using our model rocket motor test stand, find the data from that, and then let's say the max thrust of the F-15 was, what was it? I don't remember. It was like, let's just say the max thrust of a motor is 15 newtons, right? Then we get 15 newtons, put it on a weight, and see if the drone can handle that weight along with the rocket's weight. And then we go along with the project and see if that thing is useful. So yeah, Jared, quadcopter drone, or it's going to be a quadcopter drone. So yeah, it's a pretty small one. So it used for the ignition system. Of course, if you're gonna have it up in the air, hypothetically, it's gonna need a wireless system because you can't go around with a wire attached to it. So we're actually using the same components in that drone as we do in our wireless launch pad, and then where it's gonna have a blast deflection plate, and then that's gonna keep the components safe. So yeah, you guys want a picture? Let's put it in the chat. Do you guys want a picture? Yeah. So the drone is just a UAV part where the rocket launch goes off of it. So that's our project. Tell me what you think. So, anyways, I brought the rocket over. So this is our Majestic rocket. It's the 2-inch or 51mm rocket. So I just want to measure this rocket out because I like the dimensions of this rocket. So let's see. So this body tube is 2 inches by 13.5 inches. So let me lay this out. And then let's have this. So this rocket is around 31 inches. So that means we're going to need at least 3. So I think I want our rocket to be a bit longer than this. So I want it to be a bit longer than this. So I'm going to try something else. So let's see. How does peak thrust affect payload capacity of drone? Wouldn't it be a rocket weight? So to answer your question, rocket weight is one part of it, and the drone can easily handle rocket weight. Like that, the drone's super powerful. It's like 600. Like it can totally handle that. But um, the problem is when the rocket ignites, the motor is pushing down on the on the drone as well. So we could have like done a test using a load cell and have a load cell right here, right, and then the pad, and then have a motor on top, and then have the thrust going down on that. But I think it was just cooler and more useful to make the just measure the thrust of that. So peak thrust, how it affects it is the drone goes up in the air, holds a rocket, the rocket launches, and that pushes the drone down. So we want to measure that. So it's not like the most accurate way to measure that, but we're just doing it because it's cool and just to go over and make sure that it works. Does that answer your question? Hopefully it does. So anyways, we're probably going to use this body tube right here. So this thing is, yeah. We do realize the reaction force from the exhaust is not equal. But yeah. So a more accurate way of testing this would probably have our load cell and have the rocket engine on top of it and like blowing the force down or onto the load cell and measuring that. But we don't know yet. We might change it to that. Would that work, you think? You guys know if it would work if we had like a motor on top and then having a load cell underneath it? So while you answer that, let's see how long we're at. So 13.5, we're going to use 3 of these. That would give proper data. You could just make a bypass rather than a flame deflector. So let's see. Yeah, we could. So bypass, you're probably meaning like the slanted, right? Yeah, we could do that, but the problem is the whole. I don't know how we would really make that because we don't have any metalworking tools for the blast deflection plate. We just bought one off of Estes and just screwed it on there. Yeah, we could think about that, or we could just get that test with the motor on top. Yeah, so I might have to start thinking about that. So we're just going through ideas right now for the science fair because it's happening next year, but we just want to think about it just a bit. So yeah, let's see if I can find a picture of the drone. I can try finding you one of that. So move that over here. So, oh, what is the configuration of the rocket on the drone? Hang on a second, I'll get right to you. All right. So I just found a picture of a drone design. So let me open that up for you guys. So let's see. All right, here's a picture of the drone real quick. So reaction force from rocket at launch is probably not worth worrying about. Rocket will be away and gone in a fraction. Yeah, so can you see this picture? Let's see. Oh yeah, I need to change this. Yeah. So we have tested this drone before. Like the ignition system, everything. But the problem is we're gonna move to higher powered rockets. So before we just used we were planning on just using that launch rod, not a 1/4. I think that's a 3/16. So um so the oh yeah, I can try fixing that. Let's see. Sorry, I'm new at this streaming stuff. There, can you see that? There we go. All right, so the picture's on. Oh, okay, yeah. I think what was wrong was when I went to the picture. Oh, I'm sorry, guys. When I went to the picture, I had the microphone off. Sorry about that. So here, I think when that went off, I put off the picture. Sorry. Yeah, my bad. So here's a picture of the drone right here. So that's the whole design right here. So let me go up. Reaction force from rocket at launch is probably not worth worrying about. Yeah, it's not worth worrying about, but yeah. So the reason we're using this whole test stand is because we want to integrate this test stand into the project. So if you guys could think of any ways we could somehow use this model rocket test stand with this project, that'd be great. Because the reaction force, yeah, I was thinking it probably wouldn't make much of a difference, but anyways, has a drone had a test with the launch pad on it? Yes, it has. We've flown this around. Flies very strong and very straight. And then second flight was static mass emulating rocket for payload. Yeah, so we're going to, so what we're going to do, we're just going to have a weight with a string on it. And what the string is going to do is, so we're going to have the weight, the drone's going to be flying, there's going to be a really long string and a weight, we'll hold it. And then to emulate or to simulate the rocket's thrust or the amount that the motor is pushing down on the drone, we'll drop the weight and then pick back up. And then for the rocket's weight, let's say this is a rocket, we're just going to find the weight of this rocket and then make a weight and then fly it around. And yes, we have done tests with weights, and this drone is way more than enough, than way more power than we need. So yeah, sorry about the no audio. I switched screens and I forgot about the microphone, but hopefully you can see it now. So here are the features. Number 6 is a launch ignition clips. Number 5 is a launch rod. We're going to switch that to a 1/4-inch launch rod. Number 8 is just those giant propellers. That way we have the maximum power. And then 7 is those are the antenna. So does that answer all your questions? Hopefully. So anyways, all that goes up. What about aerodynamic profile of rocket? Yeah, so previous tests, so the previous design of the drone we used, so we did do this project last year, and this is just like an improvement. And let me show you the rocket we used. Be right back. So this is a rocket, much smaller. Weathercocking would be no big deal. And this is a drone designed for this rocket, not for this rocket, this giant thing. Here's a size comparison. Yeah. So, and this is not the rocket we're using, but it's the approximate size. So we don't have to worry about weathercocking or anything. So, we're probably gonna have to, I'm gonna have to talk to the drone designer, but I don't really think that, I think we're just gonna go with launching on good weather. But if there is bad weather, if there's bad weather, we're gonna have to account for that. So I think we're gonna have to do a test with that. Maybe set up a really high speed wind, a windy day, and try flying around with a rocket on there. So we could also do that as a test as well. So let me write these all down actually, because these are awesome suggestions. I haven't thought of any of this because we just started thinking about this. So let me write these all down for you. So let me open a note. So suggestions for SF. So first of all, weathercocking, right? And PID tuning of a drone can really screw up with the extra inertia a vertical pull would make. Yeah, so the nice thing about making a drone is that you can adjust the PID manually. So when we flew the drone and had the rod on there, we can program it to calibrate for the extra weight, the launch rod and the rocket on there. So I'm not the drone expert, the other guy is, but from my understanding, after he builds the drone, he has the rod on there, he has the rocket on there, he holds it up and he has it connected to his laptop with the programmer on there. So he adjusts it, and the drone, using those adjustments, can make the can adjust the PID. So I don't think that's going to be much of a problem, especially because we've done some tests with a rod and some weights, and it didn't seem to really change it much. So anyways, let's get back to those suggestions. Weathercocking. I will put PID on there just in case because I'm not the expert. So I'll add that to our notes. So what else? Oh yeah, test stand adjustments. So yeah, let's see what else. So, let's get back to designing the rocket. Oh, PID before are going to, so having an auto switch when launch code is given would be pretty useful. All right, let me copy that. Yeah, so we can definitely program that. We can definitely program that because yeah, the launch ignition system is done with a remote control, so we can have it send a signal and have a different PID when the launch happens. So anyways, let's get back to building the rocket. If you have any questions, keep them coming. Let's see. So we're going to need 3 of these. If we have 3 of these, grab my calculator. We will have a length of 40.5 inches. So let me see how long that is. So that's really long. 40 inches. Let me compare that with this rocket here. Alright, so the length of this rocket is going to be 40.5. Yeah, thank you. Yeah, that's what I got as well. So I'm gonna take off my jacket real quick. It's getting kind of hot. So anyway, so 40.5 inches. That means it's going to be pretty much the length of this whole rocket, including the nose cone. So I think that's going to be good. So I think that's, yeah. So let's put that in the spreadsheet. So body tube. I'm just going to write things down for now, just randomly, and adjust it later. So we're going to have body tube times 3. So we're going to have, there's a link. So diameter is 2 inches, and the length will be 40.5 inches. Thank you. Inches. So we have that. Now we need a nose cone. And the problem with nose cones is on the ST's website, it's only on the ST's website, and their shipping costs more than the nose cone itself. Oh, actually, we already have a nose cone. Never mind. But in case, let's just bring it up because I need the stats. Let's see. I think it's in Pro Series 2. Does it have to be that long? Make it short. We're probably less in PID issues. Yeah, we could go shorter. Yeah, shorter. That's true. Now that I think about it, I keep trying to design a cooler rocket, not a more functional rocket. So you guys have to keep reminding me. So 2 of them will be 24 inches. No, 27 inches, right? Yeah, 27 inches. That means it'll be about this long. So 27 inches. So that's about longer than the Majestic itself, actually. The Majestic. So yeah, I think that's actually better. Are there requirements for the rocket payload capacity, max thrust? Not at the moment, no. We're just gonna keep it simple for now, but we could add that. Requirements. So yeah, that is a good idea. But payload capacity, we do have. I think I'm gonna stick with still buying 3 because I do also want to have this payload bay right here. And if you haven't seen, I made a video where I kind of made part of this. So we have the payload bay here, and then I actually use wood because I don't have any 3D printers or anything. So I just use a drill bit and wood. We have the beeper here, and then we have an altimeter attached with zip ties. And I think that'd actually be good, and it fits inside here. There's a little box here to let the pressure, and then the payload bay here. So the problem you're solving is human fighter. Yes, that is. So first problem, there's been a lot of accidents with those. Second problem, they're expensive. I think the F-35 program is like $1 trillion. Another problem is if they're a lot. It's a lot heavier. So that's the problem. Yeah. Anyways, so I think we're gonna have the same payload bay on here. And yeah, same payload bay, have this in there. So we're gonna stick with three body tubes, but we're gonna lower the length. So length without a payload bay is going to be 27 inches. All right, so cool. So we have 5 viewers so far, I think 4 or 5. So any of you, it's been Robert and Jared that's been posting the questions. Feel free, if you guys have any questions, I'd be happy to answer them. So anyway, so there's gonna be 27 inches. So payload bay, probably want it to be about the same size. So for now, let's just say it's gonna be, it's about 7 inches, 34 inches. So 34 inches. So we got the body tube down. So Robert, does 34 inches still seem too long, or do you think that's more reasonable than our previous 40.5? That is kind of close still, 34 and 40. Yeah, it's still 6 inches, so probably reasonable. Okay, thank you. Yeah, 34. And we could always cut it down, make it shorter. Yeah, we should sim it though. Yeah. So I have looking into some rocket sim. So you said OpenSim. Oh, not OpenSim. Sim. OpenRocket. Yeah, sorry, not OpenSim. So I can go ahead and download this for now. Oh, I've never heard of this. I was looking at the Rock Sim from Apogee Components, and then last year they gave us a 60-day free trial. They seemed really happy that we used it and got first, but this year they didn't really they didn't seem interested in helping us out. So yeah, OpenRocket. This type of file can harm your computer. Do you? Sure, keep. It's open. Oh, okay, cool. Yeah. Let's go. I'll go ahead and download it now if you don't mind. Oh no. So let's go over to downloads. Okay, yeah. So it's a .jar file. I don't know. How do you guys know how to open .jar files? Like, cause let's see, show in folder. So let me do my There. Does that work? Yeah, it does. I keep forgetting about audio. I'm so sorry. I'm new to this. So we're learning here. So anyways, we have this here, but I accidentally opened it with Arduino. So you guys know any apps? Let me search it up. Reinstall Java runtime environment. And go to the system section. Yeah, sorry, I keep losing audio. I keep forgetting about that. So let's see. Let me open up settings here. So we got, go to system, go to apps and features. Go back, go to system, apps and features. Let me try find this thing. Apps and features there. And then all right. Okay, I'll do that later then. Yeah, got it. Sorry guys. So we'll go back to the rocket design here. So I'll figure that out later. All right, so like before, we're probably going to be using this Pro Series 2 booster actually as our fins. A weight estimate. Weight estimate. So this rocket itself, it's not going to be this rocket, but it's going to be close to this rocket. So let me go back to here so you can see me. So this rocket here is kind of what my design is. I want the design to be like, right? Along with this eBay or this electronics bay. And then along with this payload bay, shove that in there, along with the nose cone. And then I'll add the motor weight later because I don't have any motors right now. So get the scale. All right. So I'm just giving you the weight of this rocket just because this is going to be somewhat close to the weight of our new rocket. But I'm thinking about buying 3D printed parts for the payloads. It might be a bit lower in weight, but let's give it a try. So this rocket with the altimeter, the beeper, everything weighs 341 grams. All right. So 341 grams, but we also have to add the motor weight. So let's see. I lost my mouse here. I must have run out of battery. 9 kilograms. So, oh man, I forgot my value. 342. I'll just leave that there. So 342 plus 342 plus the we're probably gonna. Oh, so you think we should just use a composite motor then? Yeah, I think we'll go with a composite. So that weighs 81 grams. So 342 plus 81 will be 423 grams. So 423 grams. That's my weight estimate. Maybe a bit lighter because we're not going to use wood as a payload bay retainers. So it might be a bit lighter. So 340, not 342. 341 plus 80. So 423 was it? 423, yeah. So I'll put that in the chat just so I don't forget. 423 grams. So that's our base weight for now. So gives you takeoff thrust to weight of 21.2. Seems high. Yeah. So, and you're talking about the Aerotech, right? So are you saying the rocket is too heavy or the rocket is too light? Because if it's too light, that we can easily solve that. Motor is too small or rocket is too light. So the motor is not powerful enough for this rocket? Motor is too big. Oh, okay. Yeah, that's the problem. So what I'm thinking about doing is making a payload bay with something. Let me think. Yeah, that seems really high actually. Yeah. We could just go with an F. It's, yeah. Okay, yeah, it's a thrust. Yes, that's true. Sorry. Anyways, we could just go with these black powder. Or we could get a longer burning motor. Yeah, so um the cool thing about longer burning motors, they make the rocket more realistic because I think they have lower thrust. But or we could just go with. So we have several solutions here. We could just use black powder. We can use a longer burning motor, or we could just try to make the rocket heavier. What do you think? So the thing with longer burning motors, let me see if I can go to Apogee. 51 millimeters or 2 inches. 51 millimeters. So we've been streaming for almost an hour now. Thanks for staying on with me, guys. Appreciate it. You could sim a warhead dummy weight. Yes, we could do that as well. Huh. Yeah, that's a good idea too. So how much... Problem is, I don't think there's any... Let me look. Missiles. Let me just search that up. Small missile. And find out what they kind of... Okay, that's too small. We need like a... F-22 missile? Sure. So... Let's search that up because I don't want to type that. Yeah, so diameter is 7 inches. That's way bigger, but we could kind of scale it down, I guess, like proportionally. So warhead weight. Warhead. 40 pounds, right? With a... So should I do it proportionally with the diameter and the weight? You think that would work? So the ratio of this rocket's diameter or the future rocket's diameter to the AMRAAM AIM-120C is 7:2, right? So that's 3.5. So we could divide. Let's see. So that means we'd have to put an 11-pound payload on it if we're doing a proportionally rocket weight ratio. Okay. So rocket weight, let's see, the mass is 3. Yeah, that'd make more sense because I don't want to put an 11-pound weight on there. So it's 335 pounds. we're gonna have to do pounds to kilogram, or not, pounds to grams, and 335. Sorry, 335. All right, so we got 151,953, and divide that by our rocket weight, which is 423 grams. So that gives us 359. So if we were to, let's see, 40, 18, 143. We'd have to put a 50-gram warhead on there. So if we were doing it, this rocket's weight, or the missile's weight to the rocket's weight, this rocket's weight, and then use that from that ratio for the warhead weight to this rocket's weight, we'd have to put a 50-gram weight on there. So that gives our weight to 473 grams. And then, so if we have 473 grams, we get a thrust to weight ratio of, let's see, that's not that much though, 50-gram increase. I don't feel like getting the thrust to weight anymore, but thrust to weight, let's do it. So we have, what was the thrust of this motor? .88 peak. 9. All right, 18.9. That's still high, isn't it? Yeah, I think that's still pretty high. So, we could just add more weight, or we could just go with a. Let's look at the motors here, and we can see if there's a place where we can get it without that hazmat rocket motors. And 29 millimeters. So I think there's like a chart, yeah. So we want, the longest burn time is gonna be 7.8, I think. Yeah, 7.8 is the longest I see. 7.8 is pretty long, yeah. Let's go back up. 7.8, so sold out. F10.8, I think this one. Yeah, we probably want a longer delay. So that gives us a 86 millimeters. So this is a long burn motor we could use. Problem is hazmat, so let's see if we can reduce that price. I don't think we'll be able to. So probably don't want to pay $294. This isn't what we want. Yeah, I think the only place we can get this is from here. I would just size them. I would size the motor and rocket down. Yeah, I think that's what I'm gonna have to do. So I could just size the motor down to this F15, not F15.0, to this F15.8. Do they even have F15.8? Oh, right here, no picture. So we could just use this, because this rocket itself, I usually have this booster on there, right? And then we use F15.0 for the single state, and that easily, yeah. So let's just scale the motor down to F15.8, and then I think I have a Walmart link right here. E16.8. We could use this, but this is kind of sketchy because it has just this weird picture right here. But We could just use regular ST's black powder motor. I don't know, guys. What do you guys think? You think that's a better solution here? Cause yeah, I don't know. Let me look through our inventory and I can see if the guy has some extra motors. Yeah, I think I did check Hobby Lobby. So Hobby Lobby, yeah, they don't have that. I don't think they have that. Last time I checked, they were out of stock. It seems everyone's out of stock with that coronavirus, but F15 motor. Let me just check if the guy has it though first. Guessing on so let me tell you my plan about the fins. There's not really good fin places, like places where you can buy fins or balsa wood. So I was thinking what I could do is just buy this Pro Series 2 booster. Comes with fins, motor mount, everything. Because also motor mounts, they don't carry retainer rings. And just glue that on there. But it shows almost 5 calibers for CG ahead of CP, so it's very stable. So we were looking through and we're thinking that the Aerotech motor is too powerful, so we might just go with a standard ST's F motor, Robert. So oh, I searched that already. Let me just search rocket motor. Oh, that's what you. So you send it with the F. All right. So yeah, it should be stable because it's pretty much the same design as this thing. So is the stream still working? Yeah, I think it is. Oh yeah, I can't really find anything on Hobby Lobby. Let me see if the guy has it. Oh, actually, I know why I don't have it. It's because I deleted all the photos. But yeah, I'll find out if I'll figure out the engine stuff. So let's get with the other design. Yeah, but it's a very stable. It's very stable. It's typically only need 1 to 1.5x caliber. Okay, so the design is stable. Sweet. So I'm thinking for the fins and motor mount, I'm just thinking just gluing this on to the bottom of a body tube, and this just works as our motor mount and fin assembly. Super strong, and just gluing this. Ooh, sorry. Gluing this thing on to the body tube. So I think you think that that's gonna work. So also think it would work. Okay, thank you. Yeah, that's what I thought. All right, so we got the fins down. Nose cone, just the same one. So I think we got the basic design down of the rocket. So we'll get together sometime, and I think we kind of got the base parts of the rocket down. I'm gonna have to. I have something going on at around 4:15, so I'm gonna have to get ready for that. So it was super fun hanging out with you guys, and next time I'll try to have the other guy on, the drone dude, and we'll discuss the things and we'll discuss all the notes that we took. And yeah, so what did you guys think of the live stream? You think we should try it again? So you think if we did this again, would you guys hang out with me or us, and then also maybe ask other people on? You guys think? Because I think it turned out great. I learned a ton with you guys, and I appreciate all that help that I got. So yeah, we got 4 viewers. good start to our 2-month-old channel. So, I think I just landed from the right, like a bit of a. All right, cool. So, Robert, if you have Facebook, I can put that link in the chat for you. We also have a Facebook page, and that will probably always have the links there. And it put that into chat. So that'll always have the new links up. So yeah. Cool guys. So thanks for hanging out with us, and hope you guys think that our project is a cool idea. This week we're going to be working on the iAdmin Oregon Rocketry Facebook. Oh, cool. Yeah, I can go ahead and join that right now. But yeah, this week we're gonna start filming the wireless launchpad video in case you're interested in building that. And let me see if I can find you some more footage of that drone thing. So give me a sec here, guys. So, all right.
Are you ready?
Yep.
Let me move this to this screen here. Switch this over to here. All right. Okay. So desktop audio, yeah. So here's just a little video that we did last year. We didn't actually launch the rocket off of the drone in this case. Okay, there we go. All right, yeah, thank you, Robert. So anyways, here's just a quick video of the drone. So it starts shaking around and the drone is going all over the place, you know? But yeah, we're gonna have to, we have a lot of stuff to do, so wish us best of luck. So that's gonna be it for today. So any last moment questions? Yeah. There's a link to our website there if you guys just want to check out all the stuff. We'll see you guys later. Bye.